So welcome students. In this video, let us look at what polar coordinates of a point are. So we have already seen that in a Cartesian coordinate system, we have x-axis and y-axis, and if you take any point P on this xy plane, you can represent them using two coordinates x and y, where x coordinate is the distance from y-axis and y coordinate is the distance from x-axis. So this is one way in which we can uniquely represent a point using two distances. Now let us see another way in which we can represent this point by using a distance and an angle. So for example, if I want to represent this point, so what I try to do is I'll try to join the origin with this point P by a ray. So let us draw the ray OP. Let us draw the ray OP, that is starting from the origin and joining the point. And let us say that the distance between O and P is R. That is, P is at a distance of R from origin. So if I give this information, we know that P is at a distance of R from origin. That means P has to lie somewhere on a circle with origin as center and radius is equal to R. Now let me give another information that OP is making an angle of theta with the positive direction of x-axis. That is, using the standard convention of trigonometry. That is, counterclockwise angles are positive, clockwise angles are negative. So OP bar has a length of R and OP bar makes an angle of theta with the positive direction of x-axis. So now instead of x and y, if I give you R comma theta. So using these two numbers also, you can uniquely define the point which these coordinates represent. For example, if I say the point P is 1 comma minus pi by 4. So what point does these coordinates represent? So this says that point P is at a distance of 1 unit from origin and OP bar is making an angle of minus pi by 4 with x-axis. So to get this point, first what you do is you draw a circle with radius is equal to 1 about origin. So let us say that this is a circle with radius equal to 1. That means every point on this circle is at a distance of 1 unit from origin. Next, I want a point on this circle such that OP bar makes an angle of minus pi by 4 with x-axis. Minus pi by 4 means pi by 4 in clockwise direction. So you rotate the ray through an angle of minus pi by 4. So this will be the terminal ray. So any point on this ray has an angle of minus pi by 4 with x-axis. Any point on this circle will have a distance of 1 from origin. So now I want a distance of 1 from origin as well as an angle of minus pi by 4. So this will be the required point 1 comma minus pi by 4. So instead of x and y, we can represent the points using r comma theta also, and these coordinates are called polar coordinates of the point. These are called polar coordinates of the point. Now the important thing that you need to understand about the polar coordinates are that they are not unique. That means this point might have more than one polar coordinate. For example, 1 comma minus pi by 4 is exactly same as 1 comma 2n pi minus pi by 4. This is something we have learned in trigonometry, because even after one rotation the ray stops here. Even after two rotations the ray stops here, because angle is a periodic quantity. It just goes on, the position of the ray goes on repeating itself after every rotation. So minus pi by 4 is also same as 2 pi minus pi by 4. So if I want to rotate the angle 2 pi minus pi by 4, again the ray stops here. So something like, if I write 2 pi minus pi by 4, 7 pi by 4 also represents the same point. So what you need to understand is a polar coordinate of the point of the form r comma theta is exactly same as the coordinates r comma 2n pi plus theta. So these two represent the exact same point. So n can be any integer. So once you understand what polar coordinates are, what you need to be able to do is convert from one type of coordinates to other type of coordinates. That is, if the polar coordinates are given, you should be able to derive the Cartesian coordinates. If Cartesian coordinates are given, you should be able to derive the polar coordinates. So let us see how to get one system from the other.